hello and welcome. Today in this video I'm gonna build a new modern PC. Why it was not so easy, you will know in this video. Let's go. The package has arrived. Let's see what's inside. It's Intel i9 4900K. That's how it looks.
The power of the sun in the palm of my hand.
Damn, it's still warm. Honestly, I almost bought AMD Ryzen 7950X. Because it has more performance in Adobe Premiere Pro, it has almost the same amount of FPS in games. It's cooler and cheaper. You can watch all these benchmarks on Gamers Nexus channel. All links will be in the description. But some modern motherboards for AMD have stability issues with DDR5 memory. I know it's a kind of lottery, but for me the worst nightmare is RAM stability issue than CPU throttling problem. That's why I decided to buy an Intel CPU. Go next, it's Ramtech Liquid Freezer 2 with 420mm fans. It has great cooling performance, so I think it should handle with our CPU. Just look how huge it is. It looks bigger than 4090. Here you may notice a tiny fan, which will cool the VRAM area. Here is a proof. I noticed that the cooling surface is not flat. Will this be a problem? We'll see next. Also, we have a mounting kit for modern CPU sockets. Go next, this is ASUS ROG Strix Z790H gaming Wi-Fi motherboard. It feels like it weighs about 5 kilograms. But let's see what's inside. We have a strap, we have wire ties. They're usually included with the PC case. Also, we have an additional thermal pad for SSD and an additional screw for SSD called Q-Latch, and a sticker for those who dare. A manual, and of course we have Wi-Fi antennas. Okay, I lied, the motherboard weighs 2.2 kilograms. Looks great, and it has M.2 heatsinks. Okay, let's check the back panel. We have standard audio jacks, a new Wi-Fi gen called 6E, which makes possible to reach 9.6 gigabits. This is pretty fast. But my provider's max speed is 700 megabits, so I can show you these speeds. Also, we have a new gen USB ports, which allow you, for example, to use a fast thumb drive on the maximum speed. I have one of these. Soon I will upload the video about it. Go next, this is an NVMe SSD with 1 TB of capacity, called S880. It has PCI Express 4.0 version, which allow you to get 7000 megabytes per second. That's how it looks. I will plug it into the first NVMe slot to get max performance. It's cheap and has a 5-year warranty. It's available on Amazon. All links will be in the description. Next in the video I will test the speed. I don't think this is a good idea. I mean, to spend an extra $300 on PCI Express 5.0 SSD, which has almost the same performance, for example in loading games, as PCI Express 4.0 SSD. I know that the speed was increased, but the random read speed was still the same. Go next, this is my new hard disk with 18 terabytes of capacity. Today's games are over 100 gigabytes in size. I hope this will be enough now. I knew this day would come. I mean, when you don't have to worry about disk space. Go next, this is DDR5 memory, Kingston Fury Renegade. 2 sticks of 16 gigabytes each. I think today it's enough to have 32 gigabytes of memory on a modern PC. Guess you already know that you don't have to buy a memory with the highest frequency, because it's not so different in performance. Go next, this is RTX 4070 from Gigabyte. I know it will be a bottleneck for our CPU, and it's better to buy 4090. But first of all, I need this PC for making videos, and playing games for me is secondary. And the second reason I just can't afford it, because RTX 4090 is very expensive. Anyway, I will film all tests using RTX 4070, the results you will see next in this video. That's how it looks. We have 3 fans and a silent mode. Funny, but my cats are very like it. Hey, stop this! As you can see, 4070 is smaller than 1080. Okay, go next, this is a full modular power supply called Corsair RM850X. It has 850 watts of power. I think this will be enough for our system. After all, we don't have RTX 4090. The last component is a PC case. First, I wanted to install all these components in my previous PC, but there is a problem. The cooling system is so big that it won't fit in my previous PC case, so I need to find a bigger one. And I found it. It's called Thermaltake View71 a-rgb. The case is so big that it barely fits in my car. Also here you may notice a warning sign, must be carried by 2 people. The weight of the case is 22 kilograms without components. It was hard, but I carried it by myself. When I brought it home, I noticed that that tape was almost broke. I was lucky it didn't crash while I was carrying it. PC case covers are made of tempered glass. That's how it looks. We have 3 fans. We can install 2.5 SSDs or 7 3.5 HDDs in this case. The front panel is standard. We have USB 2.0 and USB 3.0 ports. Look, I can put my finger between the case cover, so I think the airflow here will be great and we can get better cooling performance. Okay, let's start to build the PC. Time to connect our NVMe SSD, but I have one question. Which slot should I put my SSD in? Because we have 3 slots for NVMe SSD. Is there a difference? It turned out, yes, there is a difference. Because if you will plug NVMe SSD to the lines going to the chipset, you may get latency, which can decrease your performance. The difference will be at the margin of error. It happens because the chipset is the extra step of data processing on the motherboard, which may cause latency. Also, you can get a bottleneck when devices which require more of data processing speed, such as GPU and NVMe SSD, are working at full capacity at the same time. The cause of all this is that the chipset lines are narrow. As you can see, it has 8 lines. The max speed of these lines is 16 GB per second. So to get max performance, you need to connect your GPU and NVMe SSD to the lines which are going directly to CPU. Usually they are the first slots, located nearby to CPU. It's almost done, but as you can see here, the motherboard heatsink is interfering to place liquid cooling correctly. ASUS, why did you do this to me? This motherboard must be compatible with the cooling system. No problem, I just put a rubber under the cooling system, and now it placed correctly. Okay, let's turn it on already. Oh. What hell does that mean? 1 long and 3 short beeps. Means the graphics card has been installed. I don't know what went wrong, but after I reconnected the graphics card, it turned on correctly. Now we must enable XMP profile, which must be perfectly working on Intel CPU. Let's check, and nothing happens. We have a black screen and nothing else. That which I feared came upon me. I tried to escape from RAM issues, but it caught me. First, of course, I tried to update BIOS, but it didn't help. And then I realized I installed RAM sticks in the wrong slots. My RAM was installed in the first and third slot. I don't know why, but in most cases, it's better to install RAM in the second and fourth slot. By the way, there is no information about this in the manual. Do you know what reason can cause this? If yes, please leave a comment below. And it works. As you can see now, XMP profile is enabled. Once again, I'm convinced that the most dangerous event which can happen with a computer is the user. Okay, go next, let's install Windows 11. And we have another issue. For some reason we can't connect to the internet. It happens because Windows 11 ISO doesn't have a driver for our network adapter. And without internet we can't continue the installation. Microsoft, I don't understand why I can't skip it. Don't worry, I can solve this. We need to press Shift and F10 button, then type task mgr, create new task, type explorer.x, and then find the driver. I was lucky because the network driver, which was from my old motherboard, is compatible with the new one, 1024, and I need to install the network driver before we can get access to the desktop. Oh my god, even Windows 38 was easier to install. Okay, great, we are finally on the desktop now. I forgot to show you my cable management. That's how it looks. I think it's enough. What do you think? And here is the front look. Go next, let's remove the film. Oh, looks very nice. You can change the colors using software called ASUS Aura-Sync. It has many different modes. For example, I like blue and purple gradient. It looks beautiful. 25 years of evolution, and finally, we can easily remove the graphics card by pressing this button. We all know that new CPUs are very hot, so it's time to test the temperature. I will use AIDA64 system stability test, and as you can see, all looks fine. The temperature is kept at around 88 degrees, so it's okay, we have normal temperatures. Nothing to worry about, right?
No.
I used an old version of AIDA64. If I try to run system stability test on a new AIDA64 version, I will get this. Our CPU is throttling and we have 100 degrees. Even if I try to use Intel X2 benchmark, it has also 100 degrees. It's very strange because our cooling system must handle with the heat of this CPU. So what's the problem? First, I decided to look what happens inside. As you may notice, the cooling surface is not fully adhered to the CPU. The bottom part is not adhered at all. I reassembled it several times, but the problem hasn't gone away. Looks like the cooling surface is curved. So I decided to change the cooling system under warranty. Interesting, but the store is confirmed the defect and give me a new one. Now the surface looks flatter than before. Let's try to install it. It became better, but I need to check the surface again. And my god, it's even worse than before. I reassemble it again. We have the same numbers, 96 degrees max. Let's check the surface again. As you can see, the contact area has been increased. It's strange because the new liquid cooler is cooling better, but has less contact area with the surface. We still have higher temperatures. Why did this happen? First, I don't need to test the temperature using the AIDA64 system stability test, because it extremely loads the CPU. It is better to use Cinebench R20 or R23 benchmark. And the second thing, which I was unaware of, look at the power consumption, 350 watts, goddamn. According to the official Intel page, the maximum turbo power is 253 watts. But then why did this happen? The main reason is that motherboard manufacturers, ASUS in most cases, have disabled all power limits in BIOS by default. I don't know exactly why they did this. Maybe because they wanted to show you there is a difference between 13900K and 4900K, which is within the margin of error, by the way. I know this ASUS motherboard was created for overclocking, but these behaviors also occurred in other modern motherboards. To fix this issue, we must set this option in BIOS to disabled. It enables default Intel power limits for this CPU. Okay, let's check the temperature. Now we have 88 degrees on average, but it's too hot anyway. Be sure I've tested two cooling systems with a different revision, and the temperatures are the same. I was using MX5 and MX6 thermal paste. It can mean only one thing. Intel 14900K is hot like hell. Next, I made a huge amount of tests to find out what is the best settings for 14900K, and here it is. This is Cinebench R20's course with different settings. Stack 300 watts power limit, undervolt minus 55 millivolt. This is a stable value. If I try to set more, I will get BSOD. Then we have undervolt plus 300 watts limit, overclock plus undervolt. Yes, I was trying to overclock my CPU using ASUS A Suite. We got 3 cores up to 6.2 GHz. Next we have overclock plus power limit, stack 253 watts Intel's limit, and absolutely no limits. If you didn't know, Intel has increased the temperature limit and BIOS from 100 to 115.
Oh my god!
To increase the limit, you need to set this option to enabled, remove all limits. Let's see what we got. We have 370 watts of power consumption and 107 degrees max. That's insane. By the way, the score is not so high as expected. I'm sure these temps are not good for your CPU, so I won't use it. The next chart is temperature. As you can see, almost in any case, it's throttling, except 253 watts Intel's limit, where we have 86 degrees on average. The next chart is power consumption. Without any limits, the power consumption is 370 watts. That's insane. So I don't think there is any reason to have max temperatures and insane power consumption to reach 3% of performance. It's better to stay on Intel's limit, just what I did. Of course, there is another way for better cooling, to buy a custom loop, for example, which can cost over $1,000. But does it make sense? I didn't stop there. There is another way which can decrease heat. It's called contact frame. More details review about it you can watch on Gamers Nexus channel. All links will be in the description. Many people say on forums that it can decrease only 2 to 3 degrees, others say it can decrease 10 degrees, which is hard to believe. I think it will be interesting to check. Please leave a comment, do you want to see this test on my channel? If yes, I will buy a contact frame and film the video. Go next, Intel has released an app called Intel Application Optimization.
Euro Association measured with its recommendation national association the euro.
Or Intel APO. The app can increase FPS in games due to optimization of thread scheduling. The app is definitely working. In Metro Exodus we have a 10% FPS increase. That's great, but there is no difference if you have GPU bottleneck, like in my case. When GPU is loaded 100%, the FPS amount is still the same. Funny, but first Intel said that only 14th Gen will support this feature. I don't get it. 14th Gen is already can reach high amount of FPS. Maybe it's better to support 12th Gen. Seems Intel just want to sell 14th Gen that way. Luckily, recently Intel said that 12th and 13th Gen will support APO. One more thing. Intel APO supports only one game of 10 that installed on my PC right now. I hope soon they will add other games. To make Intel APO working, you also need to enable Intel Dynamic Tuning technology and BIOS. Okay, let's test the system already. All works pretty fast. Look how fast YouTube is loading. Let's test our NVMe SSD. We have the same speed as was mentioned in the specs. The system works very fast. We have great performance. What about Premiere Pro? Everything became much smoother than it was on my previous CPU Intel i9-9900K. I am glad this is happening. Now I can make videos faster than before. I've tested how much time will take to render a short video using 4900K and 9900K. Of course I selected renderer as software only, I mean without GPU. And we have 78 seconds on 15th Gen and 119 seconds on 9th Gen CPU. 4900K is 35% faster than i9-9900K, but it was a short video. Also I've tested one of my videos, which has duration 1 hour, and you won't believe it, it rendered in 13 minutes. That's great. Go next, I overclocked my 4070. The system is working stable with these values using MSI Afterburner. It will increase GPU performance by 8%, which is really nice. The difference you will see next in this video. Okay, go next, time to test the games. I have Quad HD 144Hz rate LG monitor, so I will test the games using two resolutions, Quad HD and Full HD. Let's test control, Ultra settings, Quad HD resolution, RTX on, and we got 126 FPS on average, which is great, because we can play comfortably even on 2K monitor. Let's test the game at Full HD, with the same Ultra settings. And we got 185 FPS on average. Go next, let's test Cyberpunk. Our drive settings, Quad HD, RTX on. And we got 95 FPS on average, which is very nice on this type of graphics card. If you will change settings to Ultra, we will get 130 FPS on average. Let's try Full HD resolution, and we get 160 FPS on average. Also try to change settings to overdrive, Quad HD resolution and enable NVIDIA DLAA. We got only 37 FPS on average, but the quality is incredible. At Full HD with the same settings we have 75 FPS on average. Go next, let's test Dead Space Remake. Quad HD, Ultra settings, DLSS quality, RTX on, and we have 157 FPS on average. Go next, Fortnite. Quad HD, Ultra settings, DLSS performance, RTX on, and we have 100 FPS on average. But if we overclock our GPU, we will get 108 FPS. Let's try to play at Full HD with the same settings, and we have 130 FPS on average. Go next, Metro Exodus. 2K Ultra settings, RTX on, and we got 130 FPS on average. At Full HD with the same settings we have 170 FPS on average. And go next, let's open Minecraft. Look how quickly the textures load. Go next, PUBG, 2K Ultra settings, and we have 176 FPS on average. I don't think we need to test the game at Full HD after this. Let's try RDR2, Quad HD, Ultra settings, RTX on, DLSS quality. 126 FPS on average. Great, we can comfortably play even at Quad HD. Go next, Callisto Protocol, 2K Ultra settings, RTX on, and we have 105 FPS on average. At Full HD we have 135 FPS on average. I know 4070 is a bottleneck for this PC. It's better to use 4090 with this CPU. It will double the frame rate. But does it make sense to pay for this $2,000? The whole this PC is cost less than 4090. And if we will get more than 200 FPS on Ultra settings, also we will need a better monitor with 240 Hz of refresh rate. I think I will wait for 50 series cards, when NVIDIA can give us the real 4K performance. To sum up, we have a lot of problems with building a new modern PC. I've spent over a week to figure out what the hell is wrong with my PC. So what we have? Intel 4900K is very hot. It's almost the same as 13900K on performance. The difference at the margin of error. The performance boost is not equivalent to increase in heat. Seems it's just a marketing. The second problem is motherboard manufacturers for unknown reason disabled all default power limits for current CPU. That's why some customers, including me, think that there is a problem with their cooling system. By the way, AMD motherboards doesn't have this problem. So if you have one of these 13th and 14th gen CPUs, first of all, enable all default power limits for your CPU in BIOS. In my case, this is Enforce All Limits option, which was not enabled by default. The third problem is LJ700 socket, which deforms the cooling surface of CPU. To fix this, you need to buy a contact frame. Why should the customer deal with these issues? You are paying a lot of money and after, you must solve these problems by yourself? Anyway, this is 2024 reality. All links for components that were shown in this video I will leave in the description. You can support my channel on Patreon, soon I will upload a lot of helpful information there. Don't forget to subscribe. See you later, bye.